Okay, so hello guys, this is Wits Lounge, Learning Made Easy, and I just came across a question and decided to solve one or two questions on solubility product. So the question is, what is solubility product? It's quite simple. Solubility product simply describes the equilibrium constant for a dissolution process. So if I have a particular substance dissolved in water, let's say I have CXDY, which is a solid, and I'm dissolving this particular substance in water, what I'm supposed to get is a cation plus an anion. So where this is aqueous and this is also aqueous. Now, if I'm to balance this equation, I have x as the number of C and y as the number of D. So what I want you to take note of is anytime a substance is dissolved in water, it dissociates to form ions, which are the positive ions and the negative ions. Let's say, for instance, I'm dissolving something like CuCl2. And if I'm dissolving this, what I'm going to get is Cu2 plus, because cation, copper cation has the charge 2, is divalent, and chlorine anion. However, it's not balanced. How many copper do I have here? 1. How many chlorines do I have here? 2. So basically, this is just a repetition or a show off of how dissolution occurs. Now note, this is solid, this is aqueous, and this is aqueous. Now, if we are to go back to what we said, we specifically define solubility product as the equilibrium constant for a dissolution process. Now, what do I mean by that? This is the dissolution process, basically. And if I'm looking at solubility product, it is simply the equilibrium constant for this reaction. Now, the equilibrium constant for this reaction is active mass of C raised to power x multiplied by the active mass of D, which is negative, raised to power y. So if you look at this, we don't need to include this because the active masses of solids is equals 1. So you have this as solubility product formula. Now, where C is equals cation and D minus is equals anion. This is a general representation. You would also have that also from this, that X is number of moles of cation, while Y is number of moles of anions. So generally speaking, this is the concept behind or what we describe whenever we are looking at solubility products. Now, there is a simpler way to resolve this thing, and for you to understand the simpler way to resolve it, we are going to be considering one or two things. Okay, the first thing we are going to be considering is this. We wrote the formula to be K of S of P equals conc of C raised to power x times conc of D minus raised to power y. I presume we know what x and y is. The number of moles of C is x, number of moles of D is y. So you need to take note of that. Now, imagine for instance you are asked to find the concentration of a cation. The concentration of any ion is simply equals the concentration of the dissolved substance, or solubility. It simply equals solubility or conc of the dissolved substance multiplied by the number of moles of ion. So what this simply means is that the concentration of C is going to be equals solubility of CD, that's Cx dy, multiplied by the number of moles of C according to the balanced equation is x. Remember, the equation is Cx dy, that's supposed to be a y, Cx dy reacting to give xc plus yd minus. So that's this. So whenever I'm looking for the concentration of C, I'm going to do the solubility of this particular salt multiplied by the number of moles of C. Now, which means if I'm looking for the concentration of D, which is the anion, it is going to be solubility of Cx dy multiplied by y. So you have that. Now, whenever you're looking for the concentration of an ion, it is the solubility of the ion multiplied by the number of moles of the ion. Now, having said this, I would like to introduce this into this equation, but before that, let's take this off. We now have that, generally speaking, our solubility product is equals conc of C raised to power x multiplied by conc of D raised to power y. But we know that conc of C is equals S times x, and conc of D is equals S times Y. As we found out, where S is solubility of the salt, we know that X is number of moles of cation and Y is number of moles of anion. So if we put it in this formula, we are going to have that K of S of P is equals S times X all raised to power X. And the dot product, which is times, will now have this guy to be S times Y all raised to power Y. I'm just trying to generate a straightforward formula to solve this thing, which would make it easier for everybody. So we're going to have K of S of P is going to be equals S raised to power X times X raised to power X multiplied by S raised to power Y times Y raised to power Y. If we happen to bring this and find the common factors, the solubility product will now be S raised to power X times S raised to power Y multiplied by X raised to power X times Y raised to power Y. Eventually, our final answer would be S raised to power X plus Y multiplied by X raised to power X times Y raised to power Y. So please note this, that anytime you are asked to find solubility product, just do this and you have your answer. So rewriting the formula for solubility product, the straightforward way to find solubility product with solubility is K of S of P equals solubility of the salt raised to power X plus Y, where X is the number of moles of the cation and Y is the number of moles of the anion, multiplied by X raised to power X times Y raised to power Y. So you have that. Now, if we happen to make solubility the subject of formula, we can actually use the solubility product to find the solubility. How? Solubility will now be equals, if you know indices, well, you will know that this is X plus Y root of K of S of P divided by X raised to power X times Y raised to power Y. So just in case you're confused about this, it's probably because you have a very low foundation in indices. However, just take note of these two formulas. Now let's actually apply these two things to questions and see how it goes. Okay, now let's look at, let me put up the question on the screen. Let's consider this question. Okay, I presume that at this point we can see it. Now the question simply says the solubility product, or before we get to that anyway, I would like to say that anytime you see a question and you notice that you are giving solubility product in the question, the solubility product is what is going to be used to find the solubility. Every other thing in that question is just a distraction. So concentrate on what is the solubility product. So every other thing in the question is just a distraction. You see in this question, they say assuming neither, blah, 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 blah. All these other things they are saying are just to distract you. But then have this in mind. Yes, quite all right. They have relevance. But I'm saying for those of you preparing for JAMB exam, the most important thing you need in this question is the solubility product. And if you apply to that formula, you get your solubility straight up. Okay, now having said this, the solubility product is, okay, let's look at the question. The solubility product of Cu IO3 that's supposed to be copper 2 iodate salt is 1.0 times 10 to the power minus 7. The question now says, assuming that neither ions react appreciably with water to form hydrogen ion and hydroxyl ion, so the implication is that there is not going to be an interaction, what is the solubility of the salt? Now, you are given the solubility product and you are asked to find the solubility. Is there any formula that relates that? As we can see, yes, there is. It's right there on the screen. When you are asked to find solubility, it is equals X plus Y root of solubility product divided by X raised to power X times Y raised to power Y. Okay, so let me solve this quickly and then we'll get that. Okay, so let me get to my board. Okay, so with that said, we have that the solubility product, which is K of S of P. Solubility product is K of S of P. Sorry, why is this not going out? Okay, K of S of P for the question is 1.08 times 10 raised to power minus 7. Now, the first thing you need to do before you even get to solve is to write the equation of the solution. Copper iodate is going to be dissolved in water to give copper ion plus the iodate ion. Now, how many copper ions do we have? 1. How many iodate ions do we have? We have 2. So it's now balanced. Remember, before you start solving, make sure it's balanced. Now, if you remember, X is the number of cations and the number of moles of cations here is 1, while Y is the number of moles of anions, which is what? 2. Now, the formula for solubility, when you have solubility product, is simply given as S is equals root X plus Y of k of s of p divided by x raised to the power x times y raised to the power y. If we apply this thing straight up, we'll get our answer without any issue. What is your x? X in this case is 1 plus y is 2. So you put that down. The solubility product is 1.08 times 10 raised to the power minus 7. We're going to divide that by x raised to the power x. X is 1, so 1 raised to the power 1 times y is 2, 2 raised to the power 2. If you do this, solubility is going to be equals, this is cube root 1.08 times 10 raised to the power minus 7 divided by 1 raised to the power 1 is 1 times 2 raised to the power 2 is 4. So we have 4. Now, if we happen to solve this, I'm going to use the non-calculator method to solve this thing, or solve it without calculator. I believe that we all should understand this. Now, I can change this to 108 times 10 raised to the power minus 9. And when I do that, divided by 4. Why did I do this? So that I can be able to divide this and get 27. Now with this, now I know the cube root of 27. The cube root of 27 is 3. And when you cube root this, it's going to give you 10 raised to the power minus 3. So which means that our final answer would be 3 times 10 raised to the power minus 3. And that's the solubility, basically. So whenever you have a solubility product given, just apply this formula straight up and you will get your answer straight up without any issues. Okay, so let's try out one more question, which happens to be the question I actually put out to the group. Oh, sorry, let's take this all out and then the question. Okay, yes, that should be this. Okay, so I presume we can see it. Let me try to expand it a little bit so that we can all easily see it. Okay, no, that's too much. Okay, so the question says the solubility of silver sulfate in water at 100 degrees Celsius is approximately 1.4 gram per 100 milliliters. What is the solubility product of the salt? So in this case, we are asked to find the solubility product. Now remember that I told you that once they say you should find the solubility product, it's quite simple. Solubility product is expressed by the formula. Let's go to our board. Is expressed by the formula. So what we have is solubility product is expressed by the formula K of S of P equals solubility raised to the power x plus y times x raised to the power x times y raised to the power y. Okay, so remember that x is number of moles of cation, y is number of moles of anion, basically, and s is solubility. Now in this question, we are not giving the solubility directly. However, we are giving things to find it. They said the solubility is basically 1.4 grams in 100 milliliter of water. Now, when you have this mass of solute and volume of solvent, now I would like you to note that the volume in milliliter is the same thing as volume in centimeter cube. So ml is equal cm cube. So for those of you that are in Nigeria and UK, you will notice that we use more of the centimeter cube, but those in the US use liter and the rest of that. So 100 milliliter is equivalent to 100 centimeter cube. Okay, so if we happen to want to find or solve for solubility in mole per dm cube, yes, I did mention that earlier on, this solubility has to be in mole per dm cube. So let's convert it. Let's convert this to mole per dm cube. It's going to be mass all over molar mass multiplied by 1000 all over volume in cm cube or milliliter. Now, with that said, let's look at the question again. Where is the question? Popping. Okay, so if we look at the question says the solubility of silver sulfate, so which means we are dealing with silver sulfate. And since we are dealing with silver sulfate, we'll have to find the molar mass of silver sulfate. So let's get to work. How do we find the molar mass? Very simple. Now, the molar mass of silver sulfate, that's Ag2SO4, is going to be equals 108 times 2 plus 32 plus 16 times 4. If you do that, this is going to be 216 plus 32 plus 64, and then this is going to be equivalent to 312. So we have that the molar mass is 312. Now, having said this, you would find out that if the molar mass is 312, let's now apply it to our formula and get what we want. Basically, applying this to the formula, the mass in the question is 1.4 gram. So solubility, how to get the solubility? 1.4 gram divided by the molar mass, which is 312. No, this is supposed to be 12, multiplied by 1000 all over. The volume in this case is 100. Now when we do this, 0 cancels 0, 0 cancels 0. Yeah, so let's get to that. 1.4, this is 14 all over 312. Okay, let me get my calculator for that. 14 all over 312 is going to give me, sorry, let's do that quickly. This is going to be 14 divided by 312. So what we have as our answer for the solubility, if you do this, is going to be equals, sorry, this equals 0.044, let's call this 9. Remember, mole per dm cube. Okay, so that's how we got the solubility now. But that's not all. We're not asked to find the solubility, we're asked to find the solubility product. So let me just rewrite this. So you find out that if I am to rewrite this, this is going to be solubility is equals 1.4 divided by 312 multiplied by 1000 all over 100, and what we got is 0.0, yeah, that should be 0.0449 mole per dm cube. Okay, so if for instance we decide to write the equation for this particular reaction, when you are looking for solubility product, it is simply s raised to power x plus y times x raised to power x times y raised to power y. Now, rewriting that equation, the equation is simply Ag2SO4 when it is dissociating to give 2Ag plus SO4 minus. And what does that make? It means that our x is equals 2 and our y is equals 1. Putting it in this whole equation, what we're going to get is k of s of p is equals 0.0449 raised to power 2, which is x, plus 1 times 2 raised to power 2 times 1 raised to power 1. And when we do this, we are going to have 0.0449 all raised to power 3 times 4. Everything is going to sum up to give you 3.6 times 10 raised to power minus 4. And you have that. So solubility product is simply resolved. The formula is quite easy. I've given us something that we could use to solve it directly without all the hassles, provided you know that x is number of cations and y is number of anions. Every other thing becomes simple. So just look up, I rewrite the formula again. Sp, k of s of p is simply the solubility product is equals solubility raised to power x plus y times x raised to power x times y raised to power y. Remember, x is number of moles of cations, y is number of moles of anions, s is the solubility, mole per dm cube. So if it's not the mole per dm cube, make sure you convert it before you solve, just as we did. And then the solubility of a salt, when you have the solubility product, is going to be expressed as solubility equals k of s of p divided by x raised to power x times y raised to power y with the root of x plus y. Hope this was helpful. Thank you very much for your time.